The geometric sequence is another special sequence. And it's one in which the ratio of consecutive terms is constant, unlike the arithmetic one where we added the same amount every time. Now we're going to multiply by the same amount every time. That amount that we multiply by is called the common ratio, which we denote with a little r. So when we look at this sequence 4, 10, 16, 22, to get from 4 to 10, we're adding 6. From 10 to 16, we're adding 6, and we see that every time we're adding 6. We are dealing with the same number every time, but because we're adding the same number every time, that's what makes it arithmetic, not geometric. But when we look at 3, 15, 75, 375, as we go from one to the next, we're multiplying by 5 every time. And that's what makes this one geometric. So let's look at creating a rule for all geometric series, and let's start with that same sequence that we just dealt with. And we said that as we go from one term to the next, we're multiplying by 5 every time. So if we wanted to find the fifth term, I would just multiply by 5 again. But what if I want to find, like, the 73rd term or something? Well, how we create this sequence is by starting with this first number, 3. And what we're going to do is multiply by 5 over and over and over again. But how many times? Now remember, our first term was 3, second term was 15, third term 75, and the fourth term was 375. To get to the second term, I multiplied by 5 once. To get to the third term, we multiplied by 5 twice. And to get to the fourth term, we multiplied by 5 3 times. So if I want to get to the 10th term, I'd multiply by 5 9 times. If I want to get to the 73rd term, I'd multiply by 5 72 times. If I want to get to the nth term, I'm going to multiply by 5 n minus 1 time. Now remember, repeated multiplication, 5 times 5 times 5, that's 5 to the third power. So if we want to go 5 times 5 n minus 1 times, that's 5 to the n minus 1th power. So a more general form, if we want the nth term of any geometric sequence, we're going to start with the first one and multiply by the common ratio n minus 1 times. So we want to find a rule for 4, 20, 100, 500. The nth term is going to be the first term times the common ratio n minus 1 times. Well, what's the common ratio? How do we get from here to here, and here to here, and here to here? Well, we're multiplying by 5 every time. So our common ratio is 5. 152, negative 76, 38, negative 19. Well, to get the nth term, we're going to start with our first term and multiply by the common ratio n minus 1 time. But how do we get there? Well, to go from here to here, we divide by negative 2. And from here to here, we divide by negative 2. And from here to here, we divide by negative 2. Now, the common ratio isn't what we divide by, it's what we multiply by. And dividing by a number is the same as multiplying by its reciprocal. So our common ratio is negative 1/2. And there's going to be our rule for that. Sometimes it's not going to be as straightforward. Maybe I know the fourth term and that the common ratio is 2. And I want to find the general rule. Well, I know that a sub n is the first term times the common ratio n minus 1 time. The thing I do know is what the common ratio is. That's 2. But I don't know what the first term is. Now we can use this piece of information to help us find that. Since I know a sub 4 is going to be the first term times the common ratio 3 times, and that a sub 4 is 12, we have a nice little equation to solve. All we have to do is first find 2 to the third, that's 8, and then divide by 8 and simplify. That'll be 3/2. So that means our first term right here is going to be 3/2. And there is our rule. How about if I don't know anything? We want to get it to this point where a sub n is a1 times the common ratio to the n minus 1, but I don't know the first term and I don't know the common ratio. What I do know is that a3, which is the first term, times the common ratio to the second power, is negative 48. And I know that the sixth term is the first term times the common ratio to the fifth power is 3072. So with these two pieces of information, we do have a system that we can solve. And I'm going to solve this system using the substitution method. So I'm just going to take this first equation and solve it for a1. So that means I got to take that negative 48 and divide it by r squared. Now I can take this expression, plug it in the other equation for a1. That would give me, do it in red, negative 48 over r squared times r to the 5th equals 3072. Well, r to the 5th divided by r squared, that's r to the 3rd. And if we divide by negative 48, r cubed equals negative 64. And take the cubed root, or that to the 1/3 power, and r equals negative 4. That means, back in our original equation here, r is equal to negative 4. Still not done yet. I just know, all I know now is what r is, but that can help us in this expression that we have here. We know a1 is negative 48 over r squared, which is negative 4 squared. So negative 48 over 16 is just 3. That means our first term, negative 48 divided by 16 is going to be negative 3. So that's what our first term is going to be. And there's our solution. So really, the only thing that we need to remember right now is how to find the nth term of a geometric sequence. That's the first term times the common ratio to the n minus 1th power.